Good morning everyone. Welcome to the class Easyhai Online Learning Easyhai. My name is Mahima Agarwal and I am your mathematics educator. So class, we are discussing the chapter Surface Area and Volume of class 10th. And we have discussed in this chapter various topics such as cones, cylinders, cubes, cuboids, spheres and hemispheres. And now we will come to the most important topic of the chapter, that is frustum of the cone. So first we will discuss what is frustum, how we will derive the formulas of the frustum, and then we will come to the questions related to the frustum. Okay class, so let's begin. So the first topic of the frustum, basically this is the very first topic that you will learn first time in your syllabus. Till the 9th class you were discussing many objects and many shapes in the 9th syllabus, but in 10th frustum is very new. Okay, basically the name of the topic is frustum of cone. Here it itself says that it is something related to cone, right? It means, let us assume that there is a cone, okay, of radius r, okay, of height h and slant height l. These are the quantities that we discuss in the cone. There is a slant height l, there is a vertical height that is h, and radius of the base that is r. But what if I cut this figure from its cross section? Then it will make a separate portion. This will be a separate portion and this will be a separate portion. We can say this upper part is again a cone which is smaller in size comparing to the larger cone, while the remaining part, this one part, is not cone. It is just the part of the cone, and this part of the cone is known as frustum of the cone. Is that clear? Now we have two quantities here. Basically, if I draw a separate frustum, okay, this is my frustum of cone, right? Now we have this r, same as the radius of this cone, but this is a different r. Basically we have two circular surfaces over here. In a cone we usually have only one circular surface, but in frustum we can see there are two circular surfaces. The height will be different. Can I write it as small h? And slant height is L, will also different. I will take it as L dash. Clear? Here you can understand that I have given some certain quantities to cone and the frustum. Again, in cone we have a one circular base, and in frustum we have two circular bases. I denoted them with small r and with smaller r. And height is denoted with the smaller h, and slant height of the frustum is denoted by L dash. I think it is clear to everyone that what is frustum and how I denoted its quantities. Clear? Now let's talk about that what is the difference between the formulas of cone and frustum. There will be various differences. First of all, this h is different, right? There is involving of another r, and the L is also different. When we talk about the slant height of cone, it is always equal to L is equals to what? It is equals to under root h square plus r square. According to the Pythagoras theorem, this is my hypotenuse here, this is my base, and this is my perpendicular. So directly applying this, I can say L is equals to under root h square plus r square. But what about this? Do we have a right angle triangle here? No. Actually, we have this kind of figure here. And now you have to find out L dash. How will you be able to find out this L dash? We have this quantity h, this is a small r and this is capital R. Now you have to take this h. This will be also h. And what will be the length of this remaining part? This remaining part will be equal to capital R minus small r. Right? So this will be r minus r. Right? And now you can find out L dash is equals to under root h square plus r minus r whole square. Okay, so this is the first difference when I talk about the slant height of cone and slant height of frustum of cone. Clear, kids? Now we will come to the curved surface area, their difference, how we will be able to derive the formula for frustum for when it is curved, and as well as total, because here we are having only one circular surface and here we are having two different size circular surface, right? So let's come to the formula, that how we will able to derive the formula for frustum. Okay, so let's talk about curved surface area of cone and frustum. Okay, I will draw a cone here. Okay, having radius capital R and slant height L. Now here I have a frustum. Okay, having one small r radius and one capital R radius and slant height L dash. Okay, now just think about it. We have already learned that what is the curved surface area of cone? It is pi RL, and we have also go through the proving for the same, that how we prove that it is pi RL. Now come to the frustum. If I will give you a paper sheet and fold it, what kind of figure it will make? If it is a rectangular sheet, just visualize it, think about it very carefully. What if this is a rectangular sheet and I just fold it? So what kind of shape I will obtain? I will obtain a cylindrical shape. But what if I'll give you a trapezium like sheet? Okay, if I will fold it, don't you think that it will make a such kind of figure? It will be folded over here like this. And when trapezium is being folded, it will be make a frustum like figure. Is that clear? It means the length of this shortest side will be the circumference of this smaller circle, right? And what is the radius of this smaller circle? It is a small r. Then I can say the length of this shortest side will be the circumference, means 2 pi r. Similarly, length of the larger side, it will be the circumference of the largest circle of the frustum. It means it will be 2 pi capital R. Is that clear? The distance between these two sides will be small h, and this slant height will be L dash. But once again, think about it. When this frustum like figure will be cut into from some point and will it open, it will be a trapezium like figure, but it will be look like this. it will be circular at some point, right? It will be somewhat circular. So I cannot count here h. Okay, I will take only slant height over here. Now, can I find out the area of this trapezium? Do you guys know that what is the area of the trapezium? Area of the trapezium is 1 by 2 sum of the length of parallel sides. That is, if it is A and if it is B, then it will be A plus B, and h. H means height between these, length between these two sides, right? But in case of frustum, I will use slant height as I just told you. So my formula will be 1 by 2. As I just proved that what will be the length of these two sides? It will be 2 pi r plus 2 pi capital R into L, right? I will take 2 as common and pi as common. It is upon 2 and it will be r plus r and L. Clear? Now cancel 2 and it will be pi L r plus r. And this is the curved surface area of the frustum of cone. I hope you understand what I had just done. I just open it up and broad it and just consider it as a trapezium and derive the formula for the trapezium, for the area of trapezium. And we all know that what is the area of trapezium. Since we are not given the sides but we are given radiuses of the circle, so we can find out what will be the length of the circumference. Hence it will be 2 pi r and 2 pi capital R. Directly I put the value in the formula and here is the answer. This is my curved surface area of the frustum. Now tell me, what is the difference between the curved surface area and the total surface area? It is just the curved area. Total area includes the circular or the plane surfaces also. This frustum includes 2 circular surfaces, correct? One having radius small r and one another having radius capital R. Now what will be the area of these 2 circles? For this it will be pi small r square and for this it will be pi capital R square. So can I conclude that total surface area is equals to curved surface area plus area of 2 circular surfaces, right or wrong? Right, kids? Then what is the curved surface area? It is pi L r plus r, and area of 2 circular surfaces will be pi r square plus pi r square. Now I can take pi as common. It will be r plus r L plus r square plus r square. So here this is my total surface area of the frustum of cone. Number 1, and this is curved surface area of frustum of cone. Clear? So this is how we can derive that what is the formula of frustum of cone. Clear, class? Now the very important part, that is volume. Now we will discuss volume, that how we can find out the volume of the frustum. Okay, now let's come to the volume of the frustum of the cone. Okay, so first we will discuss that what is the volume of cone. As we have already discussed that 1 by 3 pi r square h is my volume of the cone. Here I have taken radius of the cone as capital R and height of the cone as capital H. So can I write it as 1 by 3 pi capital R square and capital H. Is that clear? And for frustum, I have taken height as small h and two radiuses. One is small r, another is capital R. Clear? Now, if you will look at the figure carefully, you will see that this is the remaining part of the cone. If I cut it by a cross section, this is the remaining part of the cone. If I subtract the volume of the small cone from the entire volume, then I will be able to find out the volume of this remaining part. Is that clear? If I am having any figure like this and I have to find out volume of this part, so what I have to do? I have to subtract the volume of this one part from the entire volume. In a similar way, I have to find out the volume of this frustum. Then I will subtract this volume of the smaller region from the entire volume. Since I have already have the volume of the entire cone, that is 1 by 3 pi r square h, and what will be the volume of this smaller cone? It will be 1 by 3 pi. It is having radius small r, and what is the height? The height is h minus h. Clear? The height is h minus h. Is that clear, class? This is very important part and I will mark it as equation 1. Okay? Now, one thing you have to understand very carefully. Whenever these kind of figure is given, we have some similarities, like the ratio of the sides of two triangles is equal when they are similar. And what is similarity? Similarity basically when it is a concept of miniatures. Whenever we draw anything or we make a model of something, we follow the concept of miniature. Like, for example, if I am having assume I am having a largest triangle of so and so dimensions, and it is having 60-degree each angle. Okay, and I have to make a miniature of it. So the condition is that this miniature should also have each angle 60-degree, but the sides cannot be equal, but the proportion of the side should be equal. If this side having 10 meter of height, so the miniature should also have 1 meter, and similarly the other side should also have the same ratio. This is called the similarity. So in this triangle also, in this cone also, we will follow the rule of the similarity. In this one cone, smaller cone, that is in cone ABC, and in cone ADE. Okay, we follow the rule of similarity. Similarity in cone ABC and another cone ADE. Right? When we will follow the rule of similarity, it means that the ratio of their sides should also be equal. It means the radiuses, means the ratio of radiuses, small r upon capital R should be equal to height, means h minus h upon height. It will be equal. So can I write it as r h upon r is equals to h minus h? Clear? And I will mark it as equation number 2. Okay, now just solve it further. It will be RH is equals to RH minus R small h. Okay, here I have to find out the value of this capital H. Okay, so I will take it at one side. It will be RH is equals to RH minus RH. You can easily understand. I can take H common and R minus R, and it will be R small h. So it will be R small h upon R minus R is equals to H. Clear? So from here I am able to find out the value of H, capital H. Now I can put the values in equation number 1. Okay. Start. So according to the equation 1, here I have 1 by 3 pi r square h minus 1 by 3 pi r square h minus h. So can I put the value of h minus h as RH upon r through equation 2nd? By equation 2nd. Okay, किसमें? In equation 1st I have to put the value of h minus h. So I will write, I will take 1 by 3 pi common. Okay, and then it will be r square h minus r square h minus h. So I can take RH upon r, RH upon r, right? Now I can see that h is common in both the terms, so I will take this out of the bracket. Okay, and I will take r as a LCM. It will turn, I will take LCM, then r cube minus, it will be r minus r, this is a small r, so r cube. I hope this is clear to everyone. Now it is 1 by 3 pi capital H upon capital R, r cube minus r cube. Do you guys remember? In algebra we have learned about a formula a cube minus b cube. It was equals to what? It was equals to a minus b, a square plus b square plus ab. Did you remember? So I will apply this formula, a cube minus b cube, and here we have r cube minus r cube. So it will be r minus r, r square plus r square plus r. Clear? Now I have also the value of capital H here. Value of capital H is RH upon r minus r. So I will put the value 1 by 3 pi h is equals to RH upon r h, small h upon r minus r, and here capital R. Clear? Now it is r minus r, in another bracket it is r square plus r square plus r. Okay, now I will start cutting. This will be cutting to r and this r will be cutting to this. Now what all quantities is left over here? I will write it here. It will be 1 by 3 pi h r square plus r square plus r, and this is the volume of the frustum. Volume of frustum of cone. Clear? I don't want this to be very complicated for you, so I am just revising again. Do focus what steps I have followed over here. First of all, you just have to subtract the volume of the smaller cone from the volume of the larger cone, right? This is my equation number 1. Now, by the rule of the similarity, I find out the proportionality of the sides of the cone. Through this, I can come to the conclusion it is r upon r is equals to h minus h upon h, and solving it, I came to the value of capital H, which is equals to RH upon r minus r. Any doubt till here? Now I conclude two equations from here. I named it as equation number 2 and this as equation number 3. I directly put the value of equation number 2 in equation number 1, means h minus h. When I put the value, I got an equation in the terms of r cube minus r cube. Here I can put the formula a cube minus b cube, which is equals to a minus b, a square plus b square plus ab. So I put the value, the similar terms will be cut down, and the remaining part I have write, that is equal to 1 by 3 pi h r square plus r. And this is the volume of the frustum of the cone, and here this is the derivation. Okay, I hope you understand, and you really don't need to memorize that how we come to the conclusion over here. Okay, you just have to understand. Okay, so this was the proof of the class, proof of the volume of the frustum. Now, using all these formulas, we will solve the various questions based on the frustum, because it is a very important topic. Okay, so let's begin the question series. Okay, so now let's start the questions based on the frustum. And the first question is that the slant height of the frustum of the cone is given, that is 4 centimeter. Okay, slant height you all know. Let me take you to the through the diagram. If this is the cone and I have to take frustum of the cone, then slant height is given, it is 4 centimeter, and the circumference of its circular ends, since we have 2 circular ends over here, so circumference is given. The smaller side is having 6 centimeter circumference and the larger circle is having circumference 18 centimeter. Clear? Now we have to find out the curved surface area of the frustum. We have to find out curved surface area, means CSA of frustum. Clear? Okay, now you tell me that what all quantity are required for finding out the curved surface area of the frustum. We know, according to the formula, it is equals to pi L r plus r, right? But we don't have here the quantity of r and r. How we will find out the value of r and capital R? Since we are given the circumferences, so it means I can say 2 pi r is given 6 centimeter. So can I say pi r is given 3 centimeter? Yes. Similarly, 2 pi r is given 18 centimeter. So I can write pi r is equals to 9 centimeter, taking this and this. Okay, I will use these two quantities. Now can I write it as pi r plus r L, right? Does it make any difference? No, because in multiplication we can relocate this value here and there. Okay, so can I multiply it? Pi r plus pi r and L. Any problem? No, I can write it as pi r plus pi r into L, and we are having value of pi r and pi r. So it is 3 and it is 9, and value of L is already given in the question, that the slant height of the frustum of cone is 4 centimeter. Okay, now only calculation part is left. 9 plus 3, 12, 12 plus 12 into 4 is 48 centimeter square. Hence, the curved surface area of the frustum of the cone will be equal to 48 centimeter square. Clear class? So, nothing else but just the one short trick was there, that you have to convert circumference into the term that we can use in the formula. I turned it into pi r and directly put into the formula, put the value and calculate. The answer is 48 centimeter square is the curved surface area of the frustum. I hope you understand this question, class. This was the easiest question. Now let's discuss some difficult question. Okay, now let's come to the second question. And second question is asking for the height of the right circular cone and the radius of its circular base. Okay, two given quantities are here. One is height and radius of its circular base is given, that is 9 centimeter and 3 centimeter. Okay, if I draw it, this is a cone. Height is given 9 centimeter and radius is given 3 centimeter. Okay, the cone is cut by a plane parallel to its base. Okay, it means this is the base and we have to cut it parallel to the plane of the base. Okay, it means we are making it a frustum of the cone, so as to divide it into two parts, right? One part is this and second part is this. The volume of the frustum of cone is given. It is what? 44 centimeter cube. Volume of frustum is given. It is 44 centimeter cube. Okay. Find the radius of the upper circular surface of the frustum. It means you have to find out this one r. Okay. What all quantities is given? That the height of the cone and the radius of the base. Nothing else is given. And volume of the frustum is given. That is 44 centimeter cube. Now can you find out the volume of the entire cone? Okay. So let's find out volume of the cone. What is the volume of the cone? It is 1 by 3 pi r square h. We have given that the value of r is 3 and height is 9. So I will find out. It will be 1 by 3 pi r square means 3 square means 9 and height is again 9. So it is 9. Now I can cancel it out 3 times and it will be 9 3s are 27. It will be equal to 27 pi. Okay, I'll leave the answer in pi terms only. So the volume of the entire cone is 27 pi. Okay, and the volume of the frustum is given. Now can I find out the volume of the smaller cone by directly subtracting it? Let's do it. If I'll also convert it into pi, so it will be equal to, can I write it as 2 into 22 upon 7. So I have to multiply it 7. So I can write it 14 pi centimeter cube. Clear? Now what will be the volume of smaller cone? Of small cone. It will be equal to the volume of the large cone minus volume of the frustum. Volume of large cone minus volume of frustum So what is the volume of the large cone? It is 27 pi, and volume of the frustum is 14 pi. So it will be equal to 13 pi centimeter cube. This will be the volume of the smaller cone. Any doubt? Any concern in this question? No doubts. Okay, so I will use it further. Now just we have proved in the part of volume that how we find out the volume of the frustum. We were just learned about the similarity, concept of similarity. So here again we don't know that what is the height of this small cone and what is the radius of this small cone, but we know that this small cone is similar to this larger cone. Clear? So using similarity, again similarity, what I can do, I can equalize the proportional of the sides of the two cones, right? So can I write it as r upon 3, because I know the radius of the larger cone, is equals to h upon height of the larger cone, that is 9. Clear? Now I can find out the relationship between these r and h. It will be equal to 9r is equals to 3h, or I can say that 3r is equals to h. Clear? This my number 1, this my number 2. Okay, I have find out the relationship between small r and small h. Clear? Okay, now the only one step left, that we have to find out the volume. We have to equalize the value actually. We already have what is the volume of the smaller cone, that is 13 pi. And we already know that what is the relationship between the radius and the height of the smaller cone. So let's put the values. Volume is equals to 1 by 3 pi r square h, and this is equals to 13 pi, right? So pi cancel to pi, and I can put 3r is equals to h. It will be 1 by 3 r square, and it will be 3r. Clear? I can write h as 3r. Now cancel 3 with 3, and it is equals to 13. Now I can take r cube is equals to 13, and the radius will be the cube root of 13. It will be cube root of 13 centimeter. Hence the smaller radius of the frustum will be, that we have to find out the radius of the upper circular surface of the frustum, that is the small r. So we come to the answer that the smaller r is equals to cube root of 13 centimeter. Clear? I just have done nothing. I find out the volume of the entire cone, that is volume of the cone 1 by 3 pi r square h, which is equals to 27 pi. And don't go by my handwriting, just look at here again. It is volume of the frustum is 44 centimeter cube. I convert it into 40 pi in pi terms, then subtract it to find out the volume of the small cone. It will be equal to 13 pi. Now finding out the relationship between the radius and the height of the cone, I use the concept of similarity. When the sides has equal proportions, so 3r is equal to h. Now apply the rule. Formula 1 by 3 pi r square h is equals to 13 pi. Pi will cut to pi, 3 will cut to cancel to 3, and r cube will equal to 13. Hence r is equals to cube root of 13. So this is my smaller radius of this cone. Clear class? Okay. this was the one of type of question, and this is really important. This kind of question when come into your examiner, you guys got confused, you don't approach the right solution for this. Okay, so go practice more and more question so that you can imagine that how can we find out the solution. Okay, and this similarity concept is really handful for you. This will be very beneficial in case of cone and frustum. Okay, okay, so one more question we will discuss on frustum. Okay class, now come to the third question, and this question will comprise some parts of the question so that you will understand that how you can find out various types of solution over here. Okay, so an open container made up of a metal sheet. Okay, it is a open container, it is like this, right? Means it's a frustum shape. Clear? Now is in the form of a frustum of a cone of height 8 centimeter. Its height is given 8 centimeter with radii of its lower and upper ends are 4 centimeter and 10 centimeter respectively. Easily you can see that this is the lower part or the smaller one which is having radius 4 centimeter, and the larger surface, that is this one, will be having 10 centimeter as radius. Okay class, now come to the third question. This question will comprise many parts, so just look at the question very carefully. Now the question is an open container made up of a metal sheet. Okay, this is my open container and it is made up of a metal sheet, right? Is in the form of frustum, like you can easily recognize the shape, that is frustum of a cone of height 8 centimeter. Height is given, that is 8, with radius of its lower and upper ends. Both the radiuses are given. Lower is the 4 centimeter and upper is 10 centimeter respectively. Now find the cost of oil that can completely fill the container at the rate of rupees 50 per liter. Okay, whenever we are asked to find the rate of something that is filled into the shape completely, it means we have to find out the volume, right? It means here we have to find out the volume of the frustum. Clear? One thing. Second, find the cost of the metal used, that what amount of metal is being used to make this container. If its cost is rupees 5 per 100 centimeter square. Okay, rate is given of the oil also and of the metal also. Now for finding out the rate of the oil, we have to find out the volume, and for finding out the rate of the metal used, we have to find out the surface area, that is total surface area of the frustum. Clear? So these two things we have to find out. Okay, now let's come to one by one. First we will have to find out the volume. So let's come to the solution part. What is the volume of the frustum? As we have already discussed about it, that volume of the frustum is 1 by 3 pi h r1 square plus r2 square plus r1 r2, right? So what are the quantities we need to find out? Here is r1, r2 and height, and these all quantities are given in the question. So can I directly put the values? Let's put the values. First we will find out the volume. Okay, so it is 1 by 3 pi, h is given 8, r1 is given 4 square, r2 is given 10 square plus 4 into 10. Right? Any doubt? Let's solve it. It will be 1 by 3, pi means 22 by 7, h is 8. Solve the bracket. 4 square means 16 plus 100 plus 40. It becomes 156. It becomes 156. And when you will solve this entire equation, you will come to the answer. It will be 1307.4. Okay, and this will be in centimeter cube. Okay, this will be in centimeter cube. Now you have to find out the volume actually in liters, because the rate is given in liters. It is rupees 50 per liter. So you have to convert the unit, and we all know that 1 centimeter cube is equals to 1 by 1000 liters. Correct? 1 centimeter cube is equals to 1 by 1000 liter. It means I have to divide this equation, and I also have to multiply it with 50 because the rate is given. Now the amount required for oil, it will be equal to 1307.4 into 50 upon 1000. Clear? It will be equal to 653.71 rupees. Okay, I directly divided by 1000 and multiplied by 50 so that you directly come to the answer in rupees. Okay, so this is the amount required for oil that can fill the container completely. Okay, so this was the part number 1. Now come to the second part. It is asking that find the cost of metal used if its cost is rupees 5 per 100 centimeter square. It means now I have to find out the total surface area. Surface area of the frustum. And what is the total surface area? That is pi r plus r L plus pi r square plus pi r square, or we can say r1 r2. Okay, so do we have the value of L here? Do we have value of L here? Yes or no? No. So we have to find out the value of L. And L, how can we find out L? We just discussed that it is equals to h square plus r minus r square. Right? Let's put the value. H is what? 8 under root 8 square plus r minus r square means 10 minus 4. It is 6 square. Clear? And 8 square is 64. 6 square is 36. It will be equal to under root 100. It means it is equals to 10. Means the slant height of the frustum will be 10 centimeter. Clear? Any doubt? Now let's put the value. Pi is common. It will be r plus r, means 4 plus 10. I will directly write 14 into 10. Okay, 14 into 10 plus r square means 4 square means 16, and plus r square means 10 yani 100. Is that clear? Now solve it. It is pi, it will be 140 plus 16 plus 100 means 116. Now it will be equal to 256 pi. Right? It is equals to 256 pi. When we will solve the pi, we will get the answer. It will be equal to 716.5 centimeter square. Okay. Now the rate of the metal sheet is given rupees 5 per 100 centimeter square. So I'll take this space. Now what we have to do, it is 716.5 centimeters square, means 716.5 into 5 and upon 100, because it is per 100 centimeters square. Clear? Now when I will solve it, it will be equal to 35.82 rupees, because we are asking for cost. Clear? Hence the cost of this will be 35.82 and the cost of the oil, it will be 653.71. Clear class? So whenever we are asking for any liquid or gas or anything that is filled inside that container or in that particular shape, we have to come to the concept of volume. Or whenever we are asked for paper used, metal used, or anything, a wood used that is required to make this particular shape, in this case we have to find out the area, whether it is total surface area or it is curved surface area. It is depending upon the question completely. Clear class? I hope you understand the concept that how we can in which condition we have to apply which formula. This is the main thing. Okay, so this is all about the frustum and these kind of questions that will come into your examination. Okay, you have to also cautious about the calculation part in this chapter, because this calculation is so lengthy. Okay, now you have to practice more. I will discuss some more question on this chapter in which we will mix and match many figures and then calculate over the question on this. Clear class? But we will discuss this part in the next lecture. Till then you have to practice more and more your calculation part as well as your understanding part. Okay, so take care, bye bye, and keep practicing.